So in this video we will be looking at various convergent and diverging boundaries, and this video is specifically for various competitive exams. Before diving into the original topic, first we have to understand that what are the types of plate, what are the major plates, what are the minor plates, what is the continental plates, what is an or oceanic plate. We have to look after it, and I am assuming that everyone knows what is the interior of the earth, how the interior of the earth works, what is various discontinuities, and then we are going to look after this topic. So firstly, I would like to make you understand about continental and oceanic plates. See, we have land mass and we have water mass or body mass, right? Whatever is the land mass is your continental plate, part of the continental plate, and whatever you see in sea or oceans, that is of oceanic plate nature, right? So these are the two plates and nothing else beyond this. Continental plates are of, if I tell you something about it, see, the continental plates are made of sial, and these are made of sima. Sial is silicon and aluminium, and oceanic plate is silicon and magnesium. So this is of granite in nature, and if it is granite in nature, it is acidic. This is basaltic in nature, and that's why it is basic. Also, if we talk about density, then obviously we know that the granite density is low. So density of continental plate is low, whereas the density of oceanic plate is high density. So this density part will help you understand how the convergence and divergence happens, right? So we are moving into the topic now. So we will be looking at convergent and divergent boundaries. So let's understand what is the divergent boundary first. See, this is a landmass. We know that if this is the surface of the earth, we have crust, mantle and core. This crust part plus upper part of upper mantle, this is lithosphere, and this lithosphere is moving. This lithospheric plate is the plate which we are talking about, right? Now this plate, lithospheric plate, is moving. That's why we have earthquakes. Is moving on this semi-liquid molten state, that is asthenosphere, right? And asthenosphere is the primary concern of divergence of plate, because see, this is asthenosphere and we see plumes. These plumes are of molten magma. And see, the thing is, if I tell you that this is a magma and it is in still stage, alright, it is in asthenosphere, then why I am showing that it is coming upwards? Because our earth is moving, and due to Pylori's force, this magma which is in asthenosphere is coming upwards, and due to that, when it comes and hits this plate, lithospheric plate, some part diverge here and some part diverge here. This is the molten magma in asthenosphere. And what will happen? At one time, this will do something, that is, firstly it provides tension. There will be tension on this plate. See, now this is whole of the plate. Think that it's whole plate, and due to tension, because magma is hitting and hitting and hitting, there will be a tension, and at a point there will be a fracture. If a magma hits back to back, first there will be a stage of tension, then there will be a fracture, then there will be a fault, and ultimately there will be a crack. And this crack is nothing but your rift valley. We will be discussing about various valleys and convergent, divergence landforms in more detail in upcoming videos. So this will create a crack, and this magma will come out to the surface of the earth, and this is how volcanoes begin. Right now, see, if a magma is pushing this plate this side and this plate this side, because see, this was the whole one plate before, but now magma has converted this one plate into two plates, one there and one there. Now what will happen? There will be another plate this side, and there will be another plate this side. All right, now this is divergent boundaries, this is divergent boundaries, but same magma will happen here as well. There will be a divergent boundary here as well, but consider this point. Here the plumes are converging. Here the plumes are converging, and same in that concern. Now here if you see, it is converging, and this is a convergent boundary. Now this part which is destroyed in the asthenosphere, this will be melted and come up as fold volcanic mountain. This will come as fold volcanic mountain. We will be looking at this with various points and facts in detail in this video itself. This part of the crust has been destroyed as it has been converged, and it is destroyed by melted into the asthenosphere. Same will happen here as well, and this part will be destroyed, and there will be a formation of fold volcanic mountains. Alright, now what will happen? This plume will go down, this will go down, and the cycle continues. This is how it works, and it works in a continuous stage. Alright, now we have some convergent boundary and divergent boundary, because see, this we have taken an example of when there is a boundary here and there is a boundary there. There's two boundaries, right? But these are all continental boundaries, but we have variations itself. So we will be looking at that. But before, we have to know that this convergent boundary and this divergent boundary, this is constructive in nature. This is constructive. Why? And this is destructive. This is destructive. Because see, if a plate is coming down into a trench, there is a formation of trench here. There is a formation of trench as well here. Trench. And this part of the plate is coming down to the asthenosphere as there is a convergent of plate. This part gets melted and there is a destruction of this plate. But when the both plate converges, molten magma comes out as lava, and when it solidifies, it makes a new landform. So it's a constructive in nature. Alright. Now we will be looking at various boundaries, and first of such boundary is your convergent boundary. So we will be focusing on first convergent. First in convergent we have oceanic and oceanic. Oceanic plate and oceanic. So this oceanic plate 1 and oceanic plate 2. Now look, we know that oceanic plate is denser and continental plate is less denser. Then we know that whatever is denser will come down and whatever is less denser will stay up. Alright. And if this is an oceanic plate, this is a continental plate, this oceanic plate will is dense, so that is why it will converge down and it will then melt it into a asthenosphere, and then there will be a formation of such landforms, right? But what if there is an oceanic plate and there is another oceanic plate, both are denser? Then we have to look after, like if we are seeing that Pacific plate is converging with Atlantic plate, so we have to see that which plate is denser, right? We know that both are denser in comparatively to continental plates, but in those plate itself there could be variation in density. So like Pacific plate is more denser than Atlantic plate, so Pacific plate will come down and Atlantic plate will stay if they converges, right? So what will be the formation? If there is an oceanic plate, if this is an oceanic plate, say oceanic plate 1, and if this is a second oceanic plate, and if this is oceanic plate 2, which is more denser, then that's why it is coming down. What will happen? This part is now under asthenosphere, because see, if this is your crust, this is your mantle, and this is your core, this whole of crust and upper part of upper mantle is the solid part, and below it is asthenosphere, that is semi-liquid or molten, and it consists of magma, right? And our plates are moving on this molten magma itself. So when any plate converges, this part, the denser part of that plate, comes towards or melts when it meets asthenosphere, and when it melts, this is the melting of plate. When this plate melts as it converges with another oceanic plate, more and more lava comes up, magma, and when it comes out, it pressurizes, as we saw in constructive plate. That is our destruction, because see, when it melts down, more and more divergence will occur, and we will see there is formation. When this lava which is coming outside solidifies, it will make volcanic fold mountain. Why fold? We will be talking about this volcanic fold mountain. Why? Because there is a convergence. When we see divergence, then there will be a rift valley, and when we see there is a convergence, then we will see fold mountains, right? Now understand there will be no volcanic fold mountains here, because there is both oceanic plates. When this part will melt, it will create arcs, not mountains. I just forgot that I am talking about oceanic plate. It will create arcs. Alright. So when this plate will melt down, this basaltic plate will be melted down in asthenosphere, this part which is melted will come up and it will form volcanic arcs, like we have Japanese arc, right? Japanese islands are the prime example of arc. So arc is narrow chain of volcanic islands or mountains, right? These are the mountains, but predominantly when we are talking about oceanic plates, we talk about arcs, right? It's a mountain. It's kind of mountain. They are above the water level, right? So that is why it is known as arc. So it's a formation, landform, right? Then we have oceanic and continental. Now we have this is the continental plate margin, and this is your oceanic. Why I have diverged it down? Because it is more denser. Oceanic plate. The density is 3.0 gram per centimeters cube, and when we talk about continent, it's 2.7 gram per centimeter cube. So it is more denser, and if it is more denser, it will be falling down, right? When it converges, one plate goes down, and which plate goes down? Whichever plates having high density will go down. In continental and oceanic, we know that more density is of oceanic, so that is why it is going down. So when it goes down, this part which meets the molten magma of asthenosphere melts down, and when it melts, it makes more plumes, and there is a formation of volcanic mountains. This is your volcanic fold mountains. Alright. In the same way, we have to look one more thing. This continental margin, we can see that there are lot of rivers coming, right? There are a lot of rivers which are bringing sediments. And see what happens if you check this area of India. This is the Indian continental plate, and this is the Bay of Bengal here. So it's an oceanic plate. So Bay of Bengal is right here. There are a lot of rivers which are coming here. Lot of rivers, right? And when it converges with this plate, it forms landforms. Like we have seen Tethys Sea. What I will give you a prime example of it. When there was a Gondwana plate or Indian plate or Indo-Australian plate, and there was a Laurentian plate, and there was a Tethys Sea in it, like we know that it is Angara land. This was Gondwana land. When Indian plate hits the Laurentian plate, what happens? Whatever sediment was under the Tethys Sea was squeezed into a mountain, and that's how our Himalayan was formed. So in the same way, when rivers bring sediments along with its course and deposits on the continental margin, when a plate converges, it forms a landforms, that is your fold mountains. So there is the formation of fold mountains here. There is a formation of fold mountains here. So there is a formation of fold mountains here. How it is created? These are created because of the sediments which are brought by the river, and this volcanic fold mountain is created because whatever melted the part of the oceanic plate, that formed your volcanic fold mountain. So there is a difference between both, right? But both are of fold mountains nature. Why? Because they are converging in nature, and whenever we see convergence, there is the formation of fold mountains, and whenever we see the divergence plate, we see the formation of rift valleys or block mountains, you can say. So like we have this in India, we have Narmada river, which is flowing between our rift valley, the Vindhyan range, of course. So last is continental. So this is continent 1 and this is continent 2. Now every continent has the same, right? 2.7 grams. Now there will be no one plate is going down. There will be no such thing. Both of these continental bodies or continental margins will collide together, and there will be a formation of fold mountains, and that's all. All right. So that's the thing about convergence boundary. We have seen the divergence boundary as well. There is nothing about divergence boundary. The convergent part is done. In divergent boundary, we have seen it how there is a construction. Whatever plumes or whatever the molten magma brings out, it solidifies and creates a landform, right? Whatever you want to know, what is most crux part of it is
Continental plates are of acidic in nature, whereas oceanic plate is basic in nature, that is basaltic. That is why they have high density, and continental plates have low density, right? So one more thing you have to know, that continental plates are of granite in nature, right? They are made of granite. That is why they are acidic, of course. Oceanic plates are made of basalt, but this mantle, the part of mantle is made of peridotite rock, and whatever the mineral which is found in this rock is olivine, that is SiO4. So this is the combination of magnesium iron oxide and silicate oxide. So this olivine which is present in mantle, when heated, becomes basalt. Then basalt further converts into andesite and further converts into granite. So this is how granite becomes, or continental plates occur. One more thing you have to know, that the oceanic plates are more newer than continental plates. Why? What's the reason? Because see, there are these plumes which are going on. This cycle continues, and when this cycle continues, more and more, see what happens now, this part will be solidified, but more and more plumes will come. Then this part which is solidified will move away, all right. Then more solidification will happen. There is a construction here, but there is a destruction here. So oceanic plates keep on destroying and keeps on building, but there is not such a continental plates. So you have to know this reason, that oceanic plate rocks are new in nature, right? So this is the concept of convergent and divergent boundary. One more thing, that is transform boundary. Transform boundaries are like we have boundary 1, this is boundary 1, and this is boundary 2. They move in a vertical manner, up and down, upward and downward, and they does not create anything. There is no such construction like we have seen in constructive or destructing boundary. That's all for this video. We have covered a lot about continental plates, oceanic plates. They are major or minor plates, you can learn from it, but the crux part of this convergent divergent, which I have explained in this video.